We're back to memory diagrams. Now this gets really interesting because you know functions. Hopefully you know a little bit about objects now, but how those functions within the class access the object is pretty neat. So we're going to show you a step-by-step memory diagram on that. And again, there's going to be a lot of things that are familiar, but it's this key word on how to access items within an object by a class. That's going to be the interesting part about this whole thing. So what I want you to do for a little bit, and hit pause here right after I'm done here, is we're doing a different class, and that's date. And date has month, day, year. There's getters and setters everywhere. There's nothing tricky about this. There's two constructors on this one. We don't even use the default one for the example, so just focus on the overall constructor, non-default constructor. The code itself, you'll notice that these are just the declarations. Just think of the definitions being complete and done and in a separate file. So again, there's no tricks to this, but take a look at that for a few seconds, and I'll go into, well, frankly, our memory diagram. So here's the code that we're going to use. It's only 3 lines, if you can believe that, compared to what we just saw. So we only have 3 lines in the main here, and that is creating our instance using the non-default constructor. So we're going to fill in a month, day, and year. Then we're going to change one of the, looks like the day here, and then we're going to print the sucker out, and that's it. So we're not doing too much here, but I'll be honest. You've seen our output thing before. You've seen the identifier and the stack. This is going to fill up pretty high with all of that information. Now, again, remember, just like as we did in the previous memory diagrams, this will fill up only because when things are done, we just put an X through it. Otherwise, in reality, the stack would collapse. But we just wanted to show you what's going on behind the scenes, even if it did finish, so that you can see the overall scenario, what's going on. So let's go to our first line. So now you see the call to create the instance using the constructor. Now behind me in the wiring diagram, it looks incomplete, and that's true so far. So you see that we've set aside an identifier W, but we don't have the month, day, and year totally set up yet. The only reason why is because we got to go through the function. Now the important part is once the function is done, we'll go ahead and set everything up. But what's happening in the function is just this. Now remember, there's the implicit parameter this in our initializer list. So again, notice this is an initializer list, not just a function. And using the initializer list, you can basically pretend right here, the identifier solution, look for a local version from the parameter. There's no local values in here. If there isn't, then second, prepend it with the this symbol and symbol or key associated with that object's data member. So in reality, this arrows all in this whole initializer list. And that's why we now have the actual values in our first line in our main. So next is our call to set the day to 4 this time, and that is using a mutator function. And it's mutating because you're setting something. And again, this time we're done with date, so that's why you see that all said and gone here. But we're going to go ahead and access the day here in 1 second using the next function. And that's what's happening here. So in the setDay function, we have it doing a bunch of checks. We're making sure that the value that we're throwing in is legit. Now notice how it's handling, let's say, a negative number and a number over 31. So no matter what happens, it's still going to funnel it into 1 to 31 using this function that we have right here. Now also notice that we are using the this keyword, so we know exactly what value is going to be set from the instance or object of our class. Again, that's also the reason why we have this arrow day and then this day over here. There is a difference between the two. This one, this same day, is this day that we just passed in. Again, could you have changed the variable names differently? Yeah, that's not a bad idea, but we're lazy. So that's why you have the this.day and then going from there. So what you have in this function call, this is a normal function call that you saw in, we did wiring memory diagrams for functions. So we have a day is 4, and then the this parameter is grabbing that this.day that I was talking about before, and it's reaching for the value inside of our object. So that's how it's going to go ahead and change things around. Notice that 7 has now been changed over to 4 once that thing is all done, and we're done with that portion of the code. So next is, wrong one, is the print data function. I think you know what that one's going to do, but we need to go through the function itself, and at the very top one, so by the way, these are both doing exactly the same thing, but what's the difference is explained, and I'll explain here in a minute. In the very top print date function, we have display, day, month, and year, and it's going to access all these items that we have inside of here. But some of you say, well, why didn't you use this thing? And you can. This works just as nicely as the one above. Some will prefer this, some will prefer that. Either one work. Just remember, the only reasons why I was able to get away with not putting this in here, this keyword in here, is because notice I'm not passing any local variables, and there's no local variables here as well. So the nice part is how we work with this, the identifier resolution, is it looks for a local variable first, and if it doesn't, then go ahead and put the this in front of it. Remember before when we had the name for date, I think it was, or something, it was named something like that before, for student, there was 2 different names. There was a name being passed in and then the name portion of the student. So we had to resolve which one was which, and that's why we used the this operator and keyword. In this one, we don't have any values being passed in that are going to become local and no local period. So I can get away with this, but you're probably going to do this as well, and I personally prefer this way myself, but that's me. Notice the output obviously is going to display the 7/4 of 2015 because that's exactly what's in the item. This portion, even though it may not be spelled out, that's exactly what it's doing. It is tying itself directly to the object because of the resolution or identifier resolution portion that we just talked about. So after that is said and done, that function is done. We're going to cross it out. That's done from the heap. But the important part is that we're not done yet, because in reality, I still got this node or this object or instance that has some data in it. So what happens? Just like your normal variables, your integers, strings, whatever, as soon as it loses scope, C++ then returns that whole item back to the heap. So there is a deletion of our instance just like a normal variable would in, well, the normal programming we've done.